Hello everyone. I'm working on a resistive and capacitive series circuit, so an RC series circuit. I've given you some information already. 240 volts, 12 ohms of resistance, and 16 ohms of inductive reactance. So right off the bat, I can solve for Z using R and XC. I can use the 2 ohm values and solve for the impedance, Z. So let's take a look at that, see if I can do this for us. Z is equal to the square root of R squared plus XC squared. And in this case, I've got the square root of 12 squared plus 16 squared. At that point, I grab my calculator. 12 squared plus 16 squared equals, and then the square root of that is 20. So in this case, Z is equal to 20 ohms. So now we have an impedance value of 20 ohms. And at that point, I can figure out with the voltage and the impedance, I can solve for the current, the IT. So I can solve for IT since I have ET and Z. Let's do that. IT is equal to what was it? It's equal to ET divided by Z. So in this case, it's 240 volts divided by 20 ohms, and I don't need a calculator for that. I can figure out that IT is equal to 12 amps. So I'll write that in here, 12 amps. So now, if I know anything about series circuits, and I hope you do too, in a series circuit, current is constant throughout the circuit. So now I can start to fill in some things. I can put 12 amps right here and 12 amps right there. Now I have 12 amps and 12 ohms of resistance in this portion of the circuit. I can figure out what the voltage drop across the resistor is. And to do that, quite simply, I can solve for ER because the formula tells me it's IR times R, and IR in this case is 12 amps again times the resistance, which is 12 ohms. I don't need to put amps there. And my calculator in my brain tells me that that is 144 volts. So I can write in 144 volts there. 144 volts. I can do the same over here and solve for the voltage drop across the capacitor. I have the current and I have the inductive reactance, so I can do that. So I could solve for EC is equal to IC times XC. And IC is 12 times 16. And 12 times 16, EC in this case equals 192 volts. 192. So I can write that in here, 192 volts. Great. At this point, I can solve for P. I know the voltage, I know the current. So if I know the voltage and the current, the formula would be P is equal to I times E. I'm going to erase that and do that one more time. P P is equal to IR times ER. And I know that IR is constant. It's 12 amps throughout the circuit, times the voltage drop, which would be 144 volts. So 12 times 144 equals 1,728. 1728 watts. Those are watts. That's true power. 1,728 watts of true power across that resistor. Now I can solve for the VARS C, volts amps reactive of the capacitor. I can use the same formula but change these values, EC and IC. I can use that to solve for VARS. So let's write that down. VARS C is equal to IC times EC, and my IC is 12 times 192, I believe was my EC. Yep. So 12 times 192 equals 2,300. Hang on, VARS C is equal to 2,304. I didn't write in my power here, which was 1728. P is equal to. So the VARS in this case is 2,304. Now, if I want to solve for C, I can complete this whole portion. I want to solve for the capacitance of this capacitor, which is a 16 ohm capacitor. I can solve for C by using 1 over 2 pi f xc. And in this case, I'll have 1 over 2 pi f is 377, right? And then it would be times 16 ohms. And so let's do that. 377 times 16, and then I hit equals, and then I do 1 over x. And 1 over x tells me that it is 0.000165.78. Excuse me, no point, no decimal point. 78, which in this case is 6 decimal places. I would have a 1, 2, 3, 4, 5, 6. I could call that a 165.78 microfarad capacitor. Let's write that in there. 165.78 microfarads. And now back over to the other side. I can solve for the VA by multiplying the I times the E, or I could use another formula for VA using the P and the VARS C. So true power times VARS, volts amps reactive, true power times volts amps reactive is going to give me this, right? But I have to, excuse me, not multiply. True power and VARS, I can use this formula. I shouldn't have said multiply. So VA is equal to the square root of P squared times VARS C squared. So let's plug in those numbers. It is the square root of 1728 squared plus, boy, I'm doing that formula all wrong. I keep saying times, but it's plus. And it's plus 2,304 squared. So if I use that formula right there, 1,728 squared plus 2,304 squared equals, and then find the square root of that, it tells me 2,880 VA. 2,880. is what my VA is. And I can write that down right here, 2,880 VA. So now power factor can be found, now that I have the VA and now that I have the true power, I can find out what the power factor is. And the formula for power factor would be power divided by VA. So true power divided by the apparent power. And in this case, it's 17, oops, sorry about that. It's 1728 divided by 2880. So if I put that in the calculator, 1728 divided by 2880, that gives me 60. 0.6. I don't think that's right though. A power factor of 0.6. So that is the power, and I'm dividing it by the VA. So I think I'm right. Okay, 0.6. Power factor is 0.6. And then if I take that 0.6 second cosine, I end up with an angle theta of 53.13 degrees. And then we can write both of those in right here, 60 or 0.6 or 60%. And angle theta is 53.13 degrees. And that is an RC series circuit. Thank you.